All right, so our first order of business here is how to graph a probability distribution. And what I'm going to do here is write out the same probability distribution that we were working with a bit last week. And specifically, that was for the number of heads that you're likely to get if you flip 2 coins. So our variable, or the thing that varies and has different possible outcomes, is the number of heads in 2 coin flips. And those options, if you remember, are 0, 1, and 2. So if you flip 2 coins, either you're going to get no heads, you're going to get 1 head, or you're going to get 2 heads. The second component of the probability distribution, of course, is the probability. T. I feel like I was about to add too many I's there. So the probability. And as you'll remember, if you flip 2 coins, there's a 25% chance that you're going to get tails for both coins, so 0 heads. There's a 50% chance that you're going to get 1 head, so one of the coins you flip is going to come up heads, the other one will come up tails. And there's a 25% chance that you're going to get 2 heads, so both of the coins you flip are going to come up heads. So if you remember back a couple weeks ago when you had a frequency distribution, where you had the values of some variable and the frequency in this column here, we could graph that frequency distribution. And we can do a really, really similar thing here with a probability distribution. And so specifically what we're going to do here is put our outcome on the x-axis here, and as I'm talking, I'm realizing I'm not sure we actually went through graphing frequency distributions in this semester. Might have been another semester, and if we didn't, forget I said that. You don't need to know anything about that for what we're about to do right now. All right, so if we want to graph this probability distribution, what we're going to do here is put our outcome, which is number of heads, on the x-axis. And specifically, the possible outcomes that we have here are 0, 1, and 2. So you can either get 0 heads, 1 heads, or 2 heads. What we're going to put on the y-axis is the probability. And specifically, the probabilities that we're looking at here are 0.25 and 0.5. So to make this graph, I'll just put this as 0.25 and this as 0.5. So we're counting up in jumps of 0.25. Now we're just going to make this into something that looks like a histogram. And so for 0 heads, we're going to look at our probability here, and you can see that we have a 0.25 probability. So we're going to draw a line at 0.25, and we're going to say this is our probability for 0 heads. For 1 heads, we have a probability of 0.5, so we're going to make a bar here that goes up to 0.5 for 1 head. And for 2 heads here, finally, we have a probability of 0.25 again, so we're going to put a bar here for 0.25. So this should be relatively straightforward, and what we have here is a graph that's showing us our possible outcomes of this probabilistic event that we have here, and the probability of getting each one. So we just turned this probability distribution here that's shown in numbers to one that's shown in graph form. But what you'll remember from the last slide is that I said all of the bars add to 1. And I want to show you what that means. So we're going to say that this bar here goes up to 0.25, this bar goes up to 0.5, and this bar goes up to 0.25. And you could think of these even in little chunks of 0.25 here, where this is, we've got 0.25, this goes up to 0.25 here, then we have another 0.25 to get up to 0.5. So if you see what I did there, I just took this bar of 0.5 and I split it into 2.25 so that you can see that these are really like blocks where the area is equal to 0.25. And if you add all of these up, they're always going to add up to 1. So this bar that's 0.25 high, this bar that's 0.5 high, and this bar that's 0.25 high, however you want to divide this up, whether you're adding 0.25 to 0.5 to 0.25, or whether you're thinking of it in terms of sort of these building blocks of 0.25 each, where this goes up to 0.25 here, and then we go up another 0.25 to get to 0.5. However you're adding it up, you're going to get an area of 1. And the reason for this is that we're showing the probability here. And we know that all of our probabilities always add up to 1 because there's a 100% chance that you're going to get one of these outcomes. And so what this graph is telling us is that there's a 100% chance that you're either going to get 0 heads, 1 heads, or 2 heads, because, if you consider all the probabilities described by these 3 bars, that includes all of our possible outcomes, or a 100% chance of getting one of these different values. So again, the takeaway here is that when you graph a probability distribution, the height of the bar corresponds to the probability, and then if you add up the heights of all your bars, it's always going to add up to 1. And it adds up to 1 in the same way that you can see here if you think about these as different blocks, essentially, that each have an area. And that area is based on how high the block goes up. Okay, so it may seem a little strange that I'm telling you this, but where we're going to go in this lecture, this will actually be useful. So I'm going to head back to the lecture now, and I'm going to talk about that special kind of probability distribution that I mentioned at the very beginning, which is a normal distribution.